Good day, everyone. I am Shadrach Ogu from GIS Grandmaster Company Limited. We have this presentation to show you people how to calculate linear measurements using ArcGIS and Google Earth Pro. So from my screen, what you can see is Google Earth. This Google Earth is the image showing Delta State Polytechnic Ogwashoku. The different buildings we have there. Let me zoom in so you can see it. This is the entrance to the school. These are different landmarks within the school environment. You can see fashion and design departments and a lot of other departments around. So the aim of this video today is to show how we can calculate the distance, road distance from an aerial photograph like this. So the first thing is get the study area, the area extent, the area of interest. You can see from this box here, Ogwashoku. If you uncheck this Delta State Polytechnic, the area will leave. So this layer is the area extent, while these points is showing us the two landmarks within which have been uploaded to Google Earth. We are currently on Google Earth map. So these 2 points is the fashion and design department and Delta State Polytechnic Ogwashoku. These are the 2 points that have been uploaded to Google Earth. So these other departments that you can see here, these other buildings, is the responsibility of a student or someone can take up the project, go to these different buildings and geotag them using a GPS. So since we don't have the geotagged information, we just have to work with the ones that are openly available. Now if you look at this place, there's a road here, Awa Obikwere Road. Awa Obikwere Road. So this road here is the road that is linking this school to other neighboring communities. Okay, so at this point, what you do next is to export this layer that has been created. You export the layer that has been created. To do that, you right click on the Ogwashoku folder and then you go to save place as. It brings you to this region. So if you see here, I have already saved the place before. So Delta State Polytechnic is the study area. That's what I saved the study area with, Delta State Polytechnic. You click save. It asks if you want to replace existing. You say yes. You save the area. Now for the points, once you save the area, it automatically saves all the contents within the map, within the layers inside the folder. If you export the folder, save place as, everything within the folder will be exported. So at this point now you can see Ogwashoku. You click on Ogwashoku. Say yes. You have saved this place as Ogwashoku. The aim of doing this, let me show you. The aim of doing this is for us to take the layer here from Google Earth Pro to a layer that can be read. This layer, the KML file, you can see the save as type is KML, KMZ or KML, either which is the layer that the Arcmap can interpret. The layer is the layer Arcmap can interpret. So if you click on save, you will now open Arcmap. Here is Arcmap. Already I have imported these files. But first, before you import the file, let me create a new data frame. Click on insert data frame. Then Let me close this layer. So at this stage, we want to bring in that layer that we have exported from Google Earth Pro. What you have to do, you look for a tool that is called KML to layer. So we want to convert that KML file. KML means Keyhole Makeup Language. So we want to convert that file into the layer ArcGIS can work with. So you click on your Arc toolbox and your tools will populate. So we go to conversion to under conversion to you click on KML to layer. So we want to convert it from KML to layer. So let's read here. Say convert KML or KMZ file into feature classes and a layer file. The layer file maintains the symbology found within the original KML or KML file. So what we do now is to call up the KML file as our input. So let's take Okwashu, say OK. Then the output location is where are we saving, where is Arcmap going to save this file. We'll select the output folder. I've been able to calculate the get in the road network layer within the school premises so that we will know what are the distances, the lengths of each of the roads within the school premises. So for us to do that, we have to call up the road network layer by clipping from the entire road network within Delta States. So click your processing tool and you go to clip. So clip is a tool that will help us cut out the area of our interest. So this is the road network. We'll select. This takes a little time to come up, so let's wait for it. Okay, it's up now. So we'll select the study area, which is this. Then the output feature class is where is this file going to be saved. We'll save it as roads, put it in output, and we'll type roads here. And it's going to be a feature class data to be saved as feature class. Alright, to say save and then you click OK. So let's wait for it to come up. It'll take a little time. Let's look at our results. Current session, clip is still in progress. Okay, so you can see this is the road has been created within our study area. Now let's uncheck. You can see the two spots. This is where the point for Delta State Polytechnic of Washington is located, and this is where fashion design department is. So what we are going to do now is to check the features of the road. You click on the road layer, open the attributes table, and these are the roads we have. These are the different roads we have. All of them are service roads. So anyone you click on, it shows us the road. So the aim is we want to know the distances from here, from this point of the study area to this place, from this place to the end, each of those routes, anyone you pick, to show you from where it started to where it stopped. This other one, so we don't have the specific names of these roads, but we know there are roads there. So what we are going to do now is to calculate the distance from each point to the end, from each point to the end. So to do that, we have to create a new field, a new column. What we call column is what we call field here in the geospatial industry, field. So to create a new field, you click on the table options, I'll select add field. Here the name of the field will be road distance, road underscore distance. We'll leave it as long integer with precision of 4. Precision is how many significant figures. Say OK. Now you can see that road distance have been created. Now what we are going to do is to calculate the road distance. Calculate geometry. Say yes, you are about to calculate outside an edit session. Yes, we are calculating outside an edit session. What this is, we are not editing the map, we are not digitizing or doing any symbology on the map. So because we are not digitizing or drawing anything, we are outside an edit session. So yes, we are going to be calculating outside an edit session. We click yes. So just like we said before, you can see this is the coordinate system that this data frame is using is currently geographic coordinate system. And for geographic coordinate system, it is seeing this data frame or this data view as a 3-dimensional image. So we need to change it to a planar coordinate system so that we can calculate length, distance, linear features. So with the way it is now, we cannot calculate area. You can see length is disabled. Length is disabled. So and the unit is degree decimal. That is not what we want. So we want to calculate the length of these roads in meters. So for us to achieve that, we need to come back to this place, to the data frame, this data view, and click on data frame properties and select UTM zone 32 and OK. UTM zone 32 is a planar a projection, a projection for planes. So we have zone 31, zone 32, so everywhere on this earth is broken into different UTM zones. So you select the UTM zone 32, which is the zone where Delta states falls in. You click OK. So we have changed it to a projected coordinate system now. So if you go back to this place and click calculate geometry, yes, we can see that automatically, since we want to calculate the length, it automatically brought us to coordinate system of data frame in projected coordinate system and no longer geographic coordinate system. So projected coordinate system for zone 32, our unit of measurement is in meters. You can change the unit to yards, millimeters, miles, as the case may be, but for the purpose of this class, we're going to be using meters. You say OK. Yes, we want to calculate. So here's the answer. You can see for this first road, this one that is highlighted here, we don't have the name of the road, but this is the distance, 148 meters from this point to this point. The next one is this, from this point to this point is 354 meters. The next one is this, from this point all the way down to this point is 668 meters. The next one is this, from this point to this point is this value. So that is how to calculate the lengths, linear features for linear features. So at this point, we'll bring the lesson to a close. So just to buttress our points, what we've learned so far, we showed you how to get this data, visualize it from Google Earth Pro, which is this. This is Google Earth Pro. These are the different buildings there are within the area, within the school environment. Now this study area was picked arbitrarily. It is not that this is the exact boundary of the school. No, this is just for the sake of this demonstration. We just had to pick off this area. Now these are the different road network within the school premises, and these are the different buildings within the school premises. We have been able to get this area and the road network into Arcmap, which is this. We've gotten the points, the lines, and the polygon feature. This is line, this is points, and this is polygon. So we've gotten them in, and we've been able to calculate the entire region of interest, and we've been able to also calculate the different road network within the school, the values, their distance, the values of the distance within the road within the school. So at this point, this will be the end of the tutorial, the training on the practical for the students, and I hope you gain some insights. I'll see you in our subsequent lessons. Bye for now. Cheers.